Alright, so in the second part of the lesson, we're going to take a look at how do we add and subtract the radicals and also how we multiply them. So first, what I want to do is I just want to remind you how to combine like terms, because you've done this already before you even did anything with radicals, and you know exactly what to do. So if I ask you to simplify 4x plus y minus 9x for me, I don't think you'd have any trouble. So hopefully you'd recognize that these are like terms and you could combine them together and you would get negative 5x, and then the y does not have a like term, so you can leave it alone, so plus y, and this would be your final answer. You'll notice that our x's did not change, so if we had a 4x and 9x, we still have negative 5x's. And we're going to use exactly the same strategy when we add and subtract radicals. So we're going to have like radicals that have the same number inside the radical. Like, so for example, square root of 10, we are going to treat them as like radicals, so we can combine them together. They're going to stay as square root of 10. The only thing that's going to change is the coefficient in the front. So here we have 4 radical 10 minus 9 radical 10, and 4 minus 9 is going to give us negative 5. So the square roots of 10 can simplify to negative 5 square root of 10. The square root of 13 did not have another term, so it's going to stay by itself. And square root of 10 and square root of 13 could not be combined together, so this will be our final answer. And that's it. Now there's only one little tricky, well, not tricky part, but there's one thing you have to remember. Before you start looking for like terms, you have to make sure that every radical is as simplified as you can possibly, or as simplified as you can make it. So for example, in part A, we had a square root of 10, which cannot be simplified, because if you try to break it up, you have a 2 and a 5 with no pairs. Square root of 13 cannot be simplified, and square root of 10 again cannot be simplified. So in part A, we didn't have to really do anything. We could just combine like terms. Now in part B, square root of 3 cannot be simplified. However, it looks like 48 could be, because it's a fairly big number and we can break it up. So I notice it is even, so I know I can divide it by 2. So I break it up into 2 and 24. 24 is even again, so we're going to break it up. 12 is even again, so 2 and 6. 6 is still even, so 2 and 3. And then once I have it all broken up, I'm going to look for pairs. I have a pair of 2's, and I have another pair of 2's, which tells me that I can bring a 2 out in the front, and I can bring another 2 out in the front, and I do have a radical 3 left over. My first term that had 5 radical 3 didn't change. So I have 5 square root of 3 plus 4 square root of 3. Now, because they both have the same radical, or square root of 3, I could actually combine them together. It's going to stay as radical 3, and what's going to change is the coefficient. So I have 5 radical 3 and 4 radical 3 that I'm allowed to combine together, and 5 plus 4 is going to give me 9. So my final answer for part B will be 9 square root of 3. Alright, so pause the video and try these 4 problems to see if you understand the concept. Alright, so here are the answers with work, and hopefully you can follow. I think 3, 4, and 5 are fairly self-explanatory, where you just have to rationalize the denominator. But I do want to explain number 6 a little bit. In case if you're wondering where the 9 came from, I'd like to explain a little bit that it came from this 3 from the outside of radical 63, and it had a second 3 that came out of the radical, so we had a 3 from before and another 3. So that's where the 9 came from, 3 times 3. And because both of these were radical 7, I was able to combine them together and get 11 square root of 7. Alright. So in the next example, what we're going to do is we're going to multiply radicals together, and a couple of things that I need to tell you. When we multiply radicals together, you are allowed to multiply the outside numbers together, and the inside numbers get multiplied together, but they stay inside the radical. So for example, if you have 2 square root of 5 times 3 square root of 7, The 2 and the 3 are on the outside, so they're going to stay on the outside. So we have 2 times 3. And then we have the 2 radicals, so we have radical 5, radical 7. And then we're going to multiply these two together to get a 6, and we're going to multiply these two together to get a square root of 35. So you have to be very careful when you're working with multiplication to make sure you keep track of what's outside, what's on the inside. So first, we notice that we have a parenthesis, which means we have to use the distributive property. We have 4 times square root of 5, and 4 is not inside the radical, so it has to stay outside of the radical, times square root of 5, minus, because we have a positive times a negative, and both 5 and 20 are inside the radical, so I'm going to put them inside the radical and multiply them together. Now one thing that you could do is you can multiply these together, or you can break them up using the 5 and 20, which I think is a little easier. And you get 5 and 4, 2 and 2. And you notice that you have 2 pairs of numbers, you have a 5 and a pair of 2's, and you have nothing left over, so the second radical will actually be simplified to just 10. So you end up with 4 square root of 5 minus 5 times 2, which is going to be just 10. And that's going to be your final answer. You can't do anything else because 4 square root of 5 and 10 cannot be combined together. So that's it. In part B, you have to be a little bit more careful. You're going to use the distributive property, and you're going to remember that you should have 4 terms because you have a binomial times a binomial. So square root of 7 times square root of 7 is going to give you a square root of 7 squared, minus, we have a square root of 7 times 3 radical 2, and actually what I'm going to do is I'm going to color code this so it's easier to follow. Okay, so first I'm going to use my black color for radical 7 times radical 7, so I get 7 squared. Then I have square root of 7 times negative 3 root 2. So I get negative 3 square root of 7 times square root of 2. Then I have radical 2 times radical 7. And then I have minus 3 radical 2 times radical 2. So if you're very careful and you check all my radicals, so everything that was inside the radical stayed inside the radical, and everything that was outside stayed outside. So my first term was square root of 7 squared, which just gives me 7. My second term has a 7 and a 2. I don't have any pairs of anything, so it's just going to become negative 3 square root of 14. My second term has a 2 and a 7. There's no pairs, so I'm just going to multiply the 2 radicals together, and I get 14. And my last one, I have square root of 2 times 2, which is 2 squared. So that's actually going to give me just a 2. So it becomes negative 3 times 2, which is negative 6. And then we're not done yet because we're going to look for things that we can combine together. We notice that we have 2 rational numbers, 7 and negative 6, and we can combine them together. 7 minus 6 will give me 1. And then what I also have is I have my square root of 14s, and they both have square root of 14, so I can combine them together. What helps to write sometimes is there's a 1 here, so when you're trying to find the coefficient, you can use that. So what we have is we have negative 3 square root of 14 plus 1 square root of 14, and negative 3 plus 1 will give us negative 2. So we get negative 2 square root of 14, and that's our final answer. Alright, so pause the video and try this one example. Alright, so here's our answer. It's 9 minus 5 square root of 5, and the 9 came from the 4 plus 5, and the square root of 5 came from negative 4 minus 1 square root of 5. One thing I just want to point out, because that's something that a lot of my students mess up on, are the signs. You have to be very careful when you multiply. You had a negative times a negative when you multiplied the last 2 terms, and that gave you a positive sign, so make sure that you carefully check all your signs. Alright, here's our last example, and this is going to be probably the trickiest thing here. So when we rationalized the denominator before and we had 5 square root of 7, we were able to get rid of the square root of 7 by simply multiplying by square root of 7 times square root of 7. So what I want to show you is that this unfortunately is not going to work here. So I'm going to first show you what's not going to work, so don't write this down, but just watch me. So first, you look at this and you think, well, when I multiply by square root of 3, I'll get rid of my radical on the bottom, and you try that. So you multiply the top and bottom by square root of 3, and you correctly simplify it. And you have to distribute here, and what you notice is that my square root of 3 didn't go away, it just moved over. So it moved over from the second term into the first term. And my square root of 3 is still here, and I did not rationalize the denominator. So there's another little trick that came from factoring, and if you remember, when we multiplied a minus b by a plus b, this gave us a squared minus b squared. So these are called conjugates, where it's the same numbers, but one factor has a negative and one factor has a positive. And when we're going to multiply together, we're going to square the first term and square the second term. So that's what we're going to use here, because what's going to happen is we're going to get rid of our radicals, and they're going to completely go away from the denominator. They're not going to just move over. Okay. So you always need a plus and a minus. So if you already have a minus, then you need a plus. And I'm going to use different colors so you could see that it wasn't here before. So I have a minus, I need a plus. Everything's going to stay exactly the same. I'm just going to change the sign. Again, I can't just randomly multiply the bottom by this binomial. I have to multiply the top by the same binomial, and I do the following. And on the bottom, you shouldn't have to multiply this out. What you should see is that you have your a squared minus b squared. So you have your first term squared minus your second term squared. And on the top, I'm just going to leave it the way it is. So 9 times 2 plus square root of 3. And then what you're going to do is you're going to simplify the bottom. So 2 squared will give you a 4, and square root of 3 squared will just give you a 3, which simplifies to 1. So that's exactly what we needed. We don't have any radicals left over. It's a nice simple number. So then on the top, we're going to distribute. Alright, so on the top, we're going to distribute, and when we multiply 9 and 2, we get 18. And when we multiply 9 and square root of 3, we get 9 square root of 3. Now, because the bottom of our fraction has 1, we don't actually need to write it. So we can simplify it and write it as 18 plus 9 square root of 3. And that's the end of the lesson. So this was the second part of 11.2 lesson, simplifying radical expressions.